Hello, I'm James Macquarie, one of the founders at GLAD. This is our Breaking Down Climate Pollution podcast, in which we ask AI to generate a deep dive conversation based on a climate science or policy document we'd like to learn more about. In this episode, we ask the AI to dive into the topic of nitrous oxide, also known as laughing gas, to uncover how this greenhouse gas might be a bigger player in driving climate change than carbon dioxide. Let's dive in.
All right, get ready, because we're diving into something big today. Something most people don't even realize is a huge deal when it comes to climate change.
Yeah, it's kind of a silent but deadly situation.
Exactly. We're talking about nitrous oxide. And the scary part is it's like 300 times stronger than carbon dioxide at trapping heat.
It's true. And, while everyone's focused on CO2, this research you sent, it takes us straight to the U.S. Corn Belt.
Which, when you think Corn Belt, you think endless fields of corn, right?
Right. But here's the thing. Those cornfields are using a lot of nitrogen.
And not just from fertilizers, which is what most people think of, right? They're also planting more soybeans, and those actually add nitrogen to the soil naturally.
Yeah, they fix it from the air. So you've got this double whammy of nitrogen going into the system. And logically, you'd assume more nitrogen means way more nitrous oxide escaping into the atmosphere.
Makes sense, right? More fuel for the fire.
Exactly. And that's what this study really wanted to dig into, how much N2O is actually coming from the Corn Belt. And get this, they actually built this massive tower.
A tower, like in the middle of a cornfield.
Right in the middle of the action. This thing was tall enough to directly measure the nitrous oxide emissions, and they tracked it for 6 straight years.
Wow, talk about commitment. So what kind of surprises popped up once they started crunching those numbers? Anything unexpected?
Well, the year-to-year variation, it was way more dramatic than they thought it would be. Like, 2012 was a real eye-opener. It was the hottest year they recorded, and the nitrous oxide emissions, they were through the roof.
Okay, so a heat wave hits, things get toasty, and bam, more nitrous oxide. Seems pretty straightforward, right?
You'd think so, but here's the catch. 2012 was actually a pretty dry year overall.
Wait, really?
Yeah, what they found was that it was actually the heavy rainfall in the 2 years before 2012, plus a really wet winter right before, that really set the stage for this massive release of N2O when things heated up.
So it's like a delayed reaction.
That's a good way to put it. It's like all that moisture combined with all the nitrogen from the fertilizer and the soybeans, it created this perfect environment for microbes, and guess what microbes love to make?
Don't tell me nitrous oxide.
You got it. So even though 2012 seemed dry, it was like the soil was primed for this huge release because of what had happened in the previous years.
Wow, so we're talking about this lag effect, where the impact of those wet years didn't really show up until things heated up.
Yeah.
That could make predicting future emissions a real headache.
Exactly. And here's where it gets even more interesting. You'd think that direct emissions, the N2O coming straight from the fields would be the biggest contributor. But surprisingly, they found that it was the indirect emissions that were really driving those big year-to-year changes.
Hold on, back up a second. What are indirect emissions in this case? Is this about the nitrogen that doesn't get used by the plants?
You got it. So when that nitrogen, either from fertilizer or decomposed plants, when it's not taken up, it can leach out of the soil, especially when you have a lot of rain.
Okay, so it's basically getting washed away.
Yeah.
And what happens to it?
Well, it ends up in waterways like rivers and groundwater. And those waterways, they have their own set of microbes. And those microbes, they also break down nitrogen.
Starting to see where this is going.
And instead of releasing it back into the air where plants can use it, it gets converted, you guessed it, into even more nitrous oxide.
So even if we figure out how to manage the nitrogen in the fields, whatever happens when the rain comes is a whole other beast.
It shows just how complex these systems are and how connected they are.
Absolutely. It's way more complicated than I initially thought. And this is all without even factoring in how climate change might mess things up even more.
Yeah, that's the really concerning part.
Okay, so let's talk about those climate change implications, because if warmer temperatures and more rain mean more N2O, we could be in for a wild ride, right?
Yeah. A wild ride is a good way to put it. We already know climate models are predicting warmer temperatures in the future, and not just warmer, but also more frequent heavy rainfall, and that includes places like the Corn Belt.
And like we just talked about, those warmer, wetter conditions, it's like ringing the dinner bell for those microbes that produce all that nitrous oxide.
Exactly. And this isn't just about warmer temperatures by themselves, right? It's the combination. A warmer and wetter climate at the same time, it could really kick those microbial processes into overdrive, leading to even more nitrous oxide being released, which, well, then that just makes climate change even worse.
So it's this nasty cycle, like we're trying to make progress, but climate change is like, nope, not so fast. So does this mean that all those efforts to, like, reduce nitrogen fertilizer, they're pointless?
No, not at all, actually. Cutting back on fertilizers, that's still really important. But this study just shows that even if we get our act together on that front, climate change itself might be like working against us in the background. It could be canceling out all our hard work.
Yeah, it's kind of a depressing thought. But important to keep in mind, right? So, I mean, do we have any concrete numbers? Did the study give us any sense of how hard this is going to be?
There was one finding that really, I don't know, stuck with me. Another study, it took these climate factors into account and estimated that to stabilize N2O emissions globally, we might have to, get this, reduce nitrous oxide emission factors and per capita meat consumption, both by 50%.
50%. Both of them. Seriously. That just seems, I don't know, impossible almost.
Yeah.
Especially with more people on the planet every day. And more people means more mouths to feed, which usually means more meat. Which, of course, that brings us right back to nitrogen use in agriculture.
Yeah, no easy answers here.
Yeah.
It's a real juggling act, right? We've got to feed everyone, use our resources responsibly, A&D, tackle climate change, all at the same time. But, I mean, the first step is just understanding how all these pieces fit together.
Okay, so we've talked about the challenges, which sound pretty huge, but did this research give us anything hopeful? Anything we can actually do about this feedback loop?
You know, it's not all doom and gloom. This study actually points to something we haven't talked about yet, seasonality. Remember those 3 peaks in nitrous oxide emissions we see throughout the year?
Yeah, right. Spring thaw, early growing season, and then that late fall spike. Are you saying if we focus on those times specifically, it might be more effective?
Yeah, you got it. Those first 2, spring thaw and the early growing season, they're responsible for a whopping 80% of the total nitrous oxide emissions each year. And what's really interesting is they all happen within a pretty short window, like 150 days.
It's way less than trying to change things over a whole year, that's for sure.
Right. Targeted interventions, it's much less daunting than trying to change everything all at once. And here's where it gets really interesting because, see, some things we do to reduce emissions, like, say, we try delaying when we put out fertilizer.
Because the microbes are more active year-round and all that nitrogen just washes away.
Exactly. But other strategies, like planting cover crops, they might actually work better under these warmer, wetter conditions.
They soak it up before it can turn into nitrous oxide.
Exactly like a sponge. And it just goes to show you there's no magic bullet here, right? What works in one place or at one time might not work somewhere else.
So it's all about finding a system that works, right? Looking at what the climate's predicted to do in that specific area, when they're using nitrogen, what kind of soil they have.
It's all connected. And that's what's so cool about this research is like it's telling us to be smarter about how we manage this whole nitrogen thing, especially those indirect emissions.
It really makes you think. I mean, we started out talking about nitrous oxide from fertilizer, and now we're here talking about microbes and rain and how a changing climate is shaking everything up.
And that's what I love about these deep dives. You know, you start with one little quadrant and it just spirals into this whole web of connections and new things to think about.
Totally. But before we wrap things up, there's one thing that's been on my mind. This study, they looked at the U.S. Corn Belt, right? Which, let's be real, they've got some pretty advanced farming and resources. So if they're having a tough time with N2O, what does that mean for everyone else?
That's the million-dollar question, right? The truth is there are a lot of places struggling with even bigger obstacles when it comes to managing nitrogen and cutting down those emissions.
Right.
I mean, they might not have the fancy technology or resources that we have here.
And on top of that, a lot of those areas are already dealing with the worst effects of climate change. Droughts, floods, crazy weather, all that stuff that we know can make those N2O emissions even worse.
It's a recipe for disaster. And it just shows that it's not enough to find solutions, right? We've got to make sure those solutions are actually things people can use, that they can afford, that work in different parts of the world.
So it's about sharing what we know, supporting the farmers who are out there on the front lines every day, recognizing that this is a global problem that needs a global answer.
Couldn't have said it better myself. It's about everyone working together to find solutions that are good for the planet, A&D good for people. Which feels like a good place to wrap things up, don't you think?
Yeah, totally. Well, that was quite a journey into the world of nitrous oxide. from tiny microbes to those giant cornfields in the Corn Belt.
We saw how a little change in temperature or rainfall can have a huge impact. And hopefully, we found some paths forward, some ways to tackle these problems, especially if we understand how all these systems work together.
Absolutely. As always, we hope this got you thinking. Feeding a growing population while taking care of our planet is a tough balancing act. But with a little knowledge, some creative thinking, and by working together, I think we can actually create a better future.
Couldn't agree more. Keep asking those tough questions, everybody, and never stop exploring the world around us. Until next time.